Everybody, we're going to prove a result tonight that's dependent only on the constants, not the function itself, which seems rather extraordinary until you see the nature of the proof. The constants C and D are members of the real numbers, just like x, and often C and D are chosen just to be integers to make the computations easier. But again, C and D are constants that are real valued, and the only stipulation on our function x is that it's strictly greater than 0 for all real x. Now we're going to try to show that this function, this quotient, is always greater than or equal to 2 times the square root of the product of the two specified constants or parameters, okay? Now the very first thing we do is just some algebra right here. If you divide this original quotient, if you just split it up into two fractions as a division problem, you end up with this statement right here. And this is where it becomes real clear why the nature of the function has no bearing on the lower bound. All right, and what we do, we use this result called the arithmetic mean geometric mean inequality. And the form of that in general is if you have non-negative constants a and b, a plus b over 2 is called the average or the arithmetic mean. Okay, that's always going to be greater than or equal to the square root of the product of the two non-negative functions. All right, so you get f of x, just we're calling it a and b for now, just thinking of them as real numbers, okay, a and b. All right, now a simple example here would be like 7 plus 7 over 2. The equality occurs actually when the two inputs are equal, okay? That's equal to the square root of 7 times 7, right? So that equality condition helps us a little bit, not as far as finding the value of x where the minimum value occurs. But anyway, this happens. That's why the equality condition is present here. Otherwise, if the inputs aren't even, a plus b over 2 is strictly greater than the square root of the product. Okay. Now again, you can see it all washes out very quickly right here. Well, you've already, right up here, I've done the work for you. The f of x is actually cancel, and then you just get that this is equal to the square root of cd. This c and this d survive. F of x divided by f of x, two positive numbers that are going to, positive number that's going to cancel, okay? Now, so we can see, I think I left enough room right here. Our h of x over 2 is greater than or equal to this, so we can write down h of x is greater than or equal to 2 times the product of the square roots of the two positive constants. Okay? And again, that's what we set out to prove. So that's QED. We're done. We finished this thing. In other words, h of x gets no smaller than 2 times the square root of CD, and it's again totally independent of the choice of function, which is interesting, but it's not so interesting once you just see it's an immediate consequence of the arithmetic mean geometric mean inequality, and that's what this is called, folks. This is called the arithmetic mean. This is called the geometric mean. Now, just to make believers out of you, I used a concrete example right here. And notice I just put the 2 there for emphasis. This is the square root of x. That's the index of the radical that gets left out all the time. But I chose f of x is equal to the square root of x. I arbitrarily chose these two integer constants, c equals 3 and d is equal to 7. And when you apply what we just did to that, you get that the graph, the minimum value of h of x would just be 2 root 21. Now, if you are interested, I just mentioned to you the equality condition here to find out where it occurred. Again, we've already proved the result, but if you want to find out for what value of x it happens, all you have to do is just do 3 in order to equate these two inputs right here. So in this case, that would be 3 times the square root of x, all right, equals to 7 over the square root of x. And again, y'all, what are we doing here? We're trying to figure out for what value of x does h of x have a global minimum value, okay? And again, so these two guys right here are playing the role of A right here and B right here. So when we equate these folks, it's pretty clear that we get, you would just get X. If you multiply through by the square root of X, excuse me, if you multiply through by the square root of X, you're just going to get X. Square root of X times the square root of X is what I'm trying to say here, folks. So you get X is equal to 7 over 3 quantity squared. And that's equal to what, 49 over 9? So when X is equal to 49 over 9, we actually get the equality condition. You could check that on this particular function if you want to. If you substitute the square root of 49 over 9 in both places right here, you'll see that you do get this minimum value of 2 root 21. But anyway, folks, we finished the proof right here, and then this was just a concrete example. And by the way, this is kind of a template for AIME problems. They put a problem like this in AIME almost every year, the American Invitational Math Examination. And it's just the problem they put in the AIME competition is just a special case of this more general truth. But anyway, I think we're finished with this one. I hope you enjoyed it.